Okay, good morning, everybody. Hope you guys are doing well. Today we're going to cover section two of your review packets, and that section has to do with fractions. And today we're going to be adding, subtracting, multiplying, and dividing fractions. So I'm going to review each of those operations with fractions with you. Hopefully, this will come back to you if you have forgotten how to do it. If you do remember how to do this, then this should be pretty simple for you. So let's get started. It says we use fractions or ratios every day. A fraction is part of an entire object. It consists of two numbers, a number on the top called the numerator and the number on the bottom called the denominator. It says to add or subtract a fraction, you must have a common denominator. That part right there, most important thing when we are adding and subtracting right there. To add or subtract a fraction, you must have a common denominator. So remember, the common denominator is a number that is as big or bigger than both of the denominators that you have in your problem. So looking at our first example, example 1, we have 1/2 plus 2/3. Now, in order to add and subtract fractions, the bottom numbers need to be the same. We accomplish that through multiplication. So if you look at 2 and you look at 3 and you think, what number could I make them both into? If you're not sure, and I know this one's pretty easy, but if you're not sure about that, you can always write out multiples of each of the numbers to find out. So if I would write out 2 and then 4 and then 6 and then 8, and then I'm going to write out multiples of 3. 3, 6, 9. And you can see right there that number 6 they have in common. So 6 is going to be our common denominator. So how do we accomplish that? Well, to turn a 2 into a 6, you need to multiply it by a 3. So we're going to multiply the top and the bottom by 3. And so our new fraction that we end up with will be 3/6. And 3/6 is 1/2. That should make sense. Now the next one, 2/3, we need to multiply that one by 2 on the top and the bottom. And when we multiply that by 2 on the top and bottom, we end up with 4/6. All right, so now we have gotten both of our fractions to have the same denominator, so we can add them. Something to keep in mind when you add and subtract fractions. You only add and subtract their numerators. The denominator stays the same. So we have 3 plus 4, which is 7, and it is over 6, which is our original denominator. Now, if you notice, or you might be thinking, wait a second, I was told you can't leave the fraction like that. And you are exactly right. That is what's called an improper fraction. The reason why it's improper is because the top number is larger than the bottom number. So when that happens, you do need to reduce it into a mixed number. And so we need to determine how many times will 6 go into 7. It will go in one whole time. So 7 divided by 6 is 1, with a remainder of 1 that you place over the original denominator. And there you go. That's your final answer, 1 and 1/6. All right, moving on to example B. This problem is very similar to the last one in that we have two fractions. They have dissimilar denominators, and so we need to get a common denominator first. After we do that, we will be able to subtract in this case instead of add like the last one. So looking through with 8, we should probably let's start with 8. We have 8, and then we have 16, and then we have 24. Maybe go one more. We'll see, 32. All right. Now let's count by threes. 3, 6, 9, 12, 15, 18, 21, 24, and it kind of ran out of room there. But you see, it took us all the way up to 24 to find that common denominator. Sometimes that will happen. It takes longer, and you might have to count by quite a few numbers. But we did find it, and it's 24. So looking at the first fraction, what do we need to multiply 8 by to turn it into 24? And that would be a 3. So the top and the bottom both get multiplied by 3, and we end up with 9/24. The next fraction, we need to figure out what it has to get multiplied. 3 times what is 24? And the answer to that is 8. So we're going to multiply the top and the bottom both by 8. And when we do that, we end up with 8/24. All right, so we have two fractions. They now have the same denominator. We can proceed to subtract them, which is 9 minus 8. That gives us 1 over the original denominator, 24. And our final answer is 1/24. Okay, guys, that is the two examples I'm going to cover in the adding and subtracting fractions. So then I would want you to go and complete the next three problems on your own. I'm going to move ahead, still in section 2, to the example 2s. These problems are multiplying fractions. And so what I hope you'll find is multiplication out of all four operations that we do: add, subtract, multiply, divide. In my opinion, multiplication is definitely the easiest, and I think you'll see why here in this first example. It says in the directions to multiply fractions, multiply the numerators and multiply the denominators. If the numerators and denominators have common factors, you can simplify before you multiply by cross-canceling, and I'll discuss what that means in 1 second here. So looking at example 2, part A, you can see we have 2/5 times 1/3. Now, with fractions, numerator times numerator, denominator times denominator. You do want to look and see if we would possibly have anything to simplify. This is what they were talking about. You should look at the diagonals 2 and 3 and see if they're both divisible by the same number. If they are, you should reduce them before you multiply. It makes life easier later on when you multiply. 2 and 3 don't have a common factor. Then you want to look this way. 5 and 1 don't have a common factor. So we can't do any reducing. We're just going to multiply straight across. 2 times 1 is 2. 5 times 3 is 15, and we have our final answer, 2/15. Moving on to part B, you see we have 3/5 times 1 and 1/3. We cannot do any multiplication until we convert that mixed number into an improper fraction. The way we do that is we multiply these two numbers, 3 times 1, and then we add the top number. So 3 times 1 is 3, plus 1 is 4. So this fraction will turn into 4/3. And then I'm going to leave my 3/5 alone for now. All right, now we have an improper fraction which we can then work with. And my advice to you is if you're adding, subtracting, multiplying, or dividing fractions, and you come across a mixed number, you should always convert that mixed number into an improper fraction before you try to work with it. That should be step number 1. All right, now looking at these two fractions, we have 3/5 and times 4/5. Sorry, 3/5 times 4/3. Now, as I said in the previous question, we want to look on the diagonal to see if the diagonal numbers could be divided, both be divided by the same number. In this case, the 3's are both divisible by 3. So we're actually going to do that. We're going to do 3 divided by 3, and these cancel, and you get 1. We're also going to divide this by 3, and you get 1. And those cancel. So what you end up with now, and I'm going to rewrite it so it's a little easier to see, you have 1 over 5 times 4 over 1, because both of those numbers, 3, were divisible by 3. So you should always reduce on the diagonal if possible. It'll save you work later on in the problem. So from there, we have 1 times 4 equals 4, and 5 times 1 equals 5, and our final answer is 4/5. So I'm going to move on to the third section. I would want you to complete 13 through 18. And then I'm going to move on to the third section and show you how to do a couple of these problems here. So in the third section, well, actually this is section 2, but it's the third example, we have division. Division is almost as easy as multiplication. It's very, very similar. There's only one extra step. And many of you hopefully remember the little saying, keep, change, flip. And so that's what we're going to do here for this. Anytime you have division of fractions, you don't actually divide, you multiply. So you have to do keep, change, flip. The keep refers to the 1/3. The change refers to changing the division into a multiplication, and the flip refers to flipping always the second fraction. So keep, change, flip tells us keep the 1/3, change it to multiplication, flip the second fraction into 2 over 1, and from there we're going to multiply straight across. We have 2 over 3. 1 times 2 is 2, 3 times 1 is 3. And that's that. It's pretty simple. Part B, we have 3/8 divided by 2/3. Again, division, first thing you do, keep, change, flip. So we're going to keep the 3/8, change the operation, flip the second fraction. Now we can multiply. Before we multiply, you should look on the diagonal to be sure nothing will simplify. 8 and 3 do not have a common number that will divide out of both of them, so they're good. 3 and 2, they also do not have a common number that will divide out of them, so we're going to leave that alone, and we can just multiply straight across. 3 times 3 is 9. 8 times 2 is 16, and our final answer is 9/16. Okay, guys, hopefully that made sense to you. I actually am going to go over part C um, because there's a mixed number along with division. I'll show you how to deal with that. So we have 3/4, keep, change the sign, and then we need to flip. But uh-oh, how do we flip that? Well, we can't yet. We have to convert that into an improper fraction. And as we said, 2 times 2 is 4, plus 1 is 5. That gives me 5 over 2. So 2.5 is 5/2. So if we keep the 3/4, change the sign to multiplication, and flip 5/2, we end up with 2/5. And then from there, we're going to multiply. Before we multiply, we look on the diagonal. 3 and 5, there is no common factor, so we leave that alone. But if we look at 2 and 4, those have a common factor. They're both divisible by 2, so we're going to do that. Each one of those highlighted numbers are going to get divided by 2. So when I do 2 divided by 2, it turns into 1. And when I do 4 divided by 2, it turns into 2. And so now we have 2 new numbers there. The reason why we reduce there is whenever we go to multiply now straight across, our answer shouldn't need to be reduced. So 3 times 1 is 3, and then 2 times 5 is 10, and we get 3/10. All right, guys, hopefully that made sense. Hope you're all doing well. I will see you tomorrow in our live Google Meet. Take care.